Yay, okay. I almost forgot to start the camera, which doesn't do you any good to try to post your talk if you don't actually record it. That's kind of an issue. So, Einstein was a character. Anybody ever read any of the books on Einstein, Rhodes' book or anything like that? Most of the books are about that thick. They're like 700-800 pages. And you find out that Einstein was a very gregarious, interesting fellow. He loved to go to coffee shops and drink very strong, usually espresso coffee, gallons of it every day. And he would talk about everything, but especially when it came to math and the nature of the universe. He was a clerk in a patent office in 1905 when he wrote his first paper on relativity. And at first, the general audience wasn't too impressed because they'd never heard of the guy, nor did he have a doctorate at that point. He was working in the patent office because he had to do something to make a living, and he couldn't get a job in academia. So, oh, by the way, did you know that Einstein got kicked out of his school? Anybody? No? Okay, so, you always think of Einstein, super smart. Everybody wants him towards the latter part of his life because he's such a great genius. But he was failing the gymnasium in Germany. He was in a German school. Gymnasium is what they called high school. And he was failing math, especially. Now, it turns out that he just didn't like the German school and how strict they were. And so he basically rebelled until they kicked him out. Then he went to school in Switzerland and did well. However, Einstein had a problem. Most people don't know about this. But if you research Einstein, even as an adult, especially after he was an older adult and he moved to the United States in between World War I and World War II, it was in 1932, I think 36, but one of the things he did is he tutored students in mathematics. And I think I may have mentioned this to you before. And the reason why he did that is because he couldn't ever remember his multiplication tables. So by tutoring students, helping them with their basic math skills, he could remember his multiplication. And the other thing is, Einstein was a good mathematician, but he wasn't a great mathematician. However, he had the ability to think and picture things, and after he did that, then he came up with the math for it. He was married to a gal who was probably a much more brilliant mathematician than him and helped him formulate relativity. And he also had friends that were totally brilliant mathematicians. So he always gets the credit, but when you read his writings, you find out he gives a lot of the credit to other people. So this is just a young Einstein. You almost always see old pictures of an older Einstein. Anybody know why they usually make pictures or show pictures of older scientists? I mean, if you look at any book, you see these old guys. Yeah.
Because usually they do their more like distinctive work when they're older, so that's when they were known as.
Actually, they usually did their work when they were younger, but by the time they really get famous, they're older. So yeah, good guess. So I just have put where I could find it, young pictures of these different scientists we're going to talk about. So this is E equals mc squared. Remember, I've talked about energy equals mass times the speed of light squared, but you can also say E equals m or m equals E. Either way. So that's the special theory of relativity. The general theory of relativity is gravitational, and I forget what the G, this is gravity also, I think it's gravitational constant, equals 8 times pi gravity divided by speed of light to the 4th power times t, which is time. And this, anybody know what this symbol is? No? I don't blame you. It's not one everybody knows. This was Einstein's shorthand for what he called the cosmological constant. And I'm going to write that down because it shows back up here in a minute. Cosmological constant. You see, back when Einstein was doing all this, scientists, especially astronomers, believed the universe was non-changing and was eternal. And there's a particular reason for that. And I'm going to get in the weeds a little bit here, but around the mid to late 1800s, scientists began to push back against religion. Not just Christian religion, but religion in general. And one of the issues that scientists had was the idea that there was a beginning to the universe. There are still scientists today who are bugged by a beginning. And so to come up with some way to have an eternal universe that would not be changing and all of that sort of thing, they had to come up with something. And so everybody had the idea that the universe has always existed, always will exist, and that nothing changes dramatically. This also precludes the idea of evolutionary or stellar evolution, where stars change over time and all sorts of stuff. So that was very popular, and Einstein really liked that. You see references to Einstein talking about God doesn't play dice with the universe, which he did say. So a lot of people assume that Einstein was a man of faith. He was not. Einstein really did not believe in God. And he also didn't like the idea of a universe with a beginning. And all the way through the 1930s, he put this figure in there. But in 1929, we're going to talk about it, a guy in the United States discovered the universe was expanding. There was hints of that before, and we'll talk about that too. But Einstein realized the biggest mistake of his life was adding this cosmological constant in here so the universe would stay static. He added this number, fudged it. Anybody ever fudge any numbers in math? I'm sure no one would ever do that. Anyway, he fudged that number, and then by 1931 retracted his cosmological constant because he realized that he was wrong. Now, there's a lot of scientists that don't do that. Remember that guy named Peter Van de Kamp that we talked about on Barnard's star? Well, he was a guy that never did admit that he was wrong, even until the day he died. So the fact that Einstein was willing to do that, I thought, made him a really great scientist, because he was able to look at his mistakes and say, I was wrong. And that's a very good thing. So Einstein came up in 1905 with the beginnings of the math for an expanding universe. But now we're going to go back and we're going to talk about another thread of history. Giovanni Schiaparelli, he observed what he called canale. Anybody know anything about Italian? Anybody do Italian or anything? I think it may be the same in Spanish. But canale in Italian means channels. Okay, so canale, right here, C-A-N-A-L-I, was translated into English as canals. So this is channel, and this is canal. You can have a channel, like a channel between two islands, and it's natural. And that's what Schiaparelli thought. He thought that these were natural features on Mars. And when it got translated into English as canals, there were some people that began to say, oh, there must be Martians that had made these canals. And so suddenly a huge controversy began. And I'm going to show you just some quick pictures here. This is Schiaparelli's Mars map. And by the way, I could not find any young Schiaparellis. And I think it's part of it is because he was one of those guys that looked about the same. All the pictures I saw 20 years apart, he looked about the same. But this is showing these channels. And he thought these channels could be natural. That's why he called them canali. And then here's a more detailed Schiaparelli Mars map where he's showing some of the features. These are called albedo features, not that you need to know that in this class. Albedo means brightness of something. So Mars, what you see is light and dark areas on Mars. You can see white polar caps, you see kind of a red or ochre surface area, and then you see these dark markings that to the human eye, especially when you're tired, they tend to look green. So when I was a kid, there were still people talking about Mars having plant life. Robert Heinlein wrote a book about that, a science fiction book where people skate on canals that the Martians build, and there's vegetation on both sides of it. So this became a really big deal in the late 1800s and the early 1900s. So step in Percival Lowell. Uncle Percy, I've mentioned him before at the very beginning of this class when we start talking about telescopes and stuff. Percival Lowell founded Lowell Observatory. And I have to admit, if you form your own observatory, I guess it's okay to name it after yourself. I call my observing station Temple Research Observatory, but it's actually named after my dad. Yes, it is my last name as well. But my father put up with me for years, bugging him about getting me telescopes. And I just kind of felt like when he passed away, that's what I would call my observing station, is Temple Research Observatory, which also defines that I don't really do a lot of just touristing or sightseeing with it. I actually do research because I think that's more fun. But Percival Lowell came out of the famous Lowell family. Percival's brother was president of Harvard University. His sister was a world famous poet. Mom and dad were incredibly sickly wealthy. And Percival Lowell, everybody thought he would be a chip off the old block. And so he went into business when he got out of Harvard, because everybody who was anybody went to Harvard. And when he got out of Harvard, he was bored out of his mind. He made a fortune. He was already rich anyway, but he made a fortune on top of that. And he was so bored, he decided to go to Asia. And I believe he wrote 2 or 3 books, The Soul of Asia, and I forget the other ones, about his travels as an envoy, special envoy for the United States government over in Asia. And when he went to Asia, he took along a 6-inch refractor. And if you look out in that case, you remember the case out here? That kind of bronze telescope? He had one just like that. And he carried that with him all through Asia and observed on just about every clear night that he could. So after doing that for a number of years, he decided to come back to the United States, and he decided he was going into astronomy. Why? Because Giovanni Schiaparelli hurt his eyes looking at the sun with a telescope, which you shouldn't do anyway. And I don't remember if he used a filter or not, but it began to affect his eyesight, and he was having to retire as an astronomer. And Lowell felt like somebody needed to, as he calls it, pick up the mantle and continue the work that Schiaparelli was doing. So Lowell had built the 24-inch Clark refractor. That is a little bit less than twice the size of the one we have upstairs. So if you think this one is big, when you walk into the dome at Lowell Observatory, that telescope is probably close to twice the size of this one upstairs. And this is pretty big. If you go to Yerkes Observatory, not Yerkes, Lick Observatory, which I'll show you a picture of that telescope in a little bit, and out in California, it's bigger than the 24-inch. And when you go to Yerkes, it has a 40-inch and it's gargantuan. I've not ever been to Yerkes, but a lot of times people walk in, stop, and the crowd bumps into them because they have this, what I call the oh my God moment. And the oh my God moment is usually what people say, but sometimes it's almost like a prayer because they did not expect to see something like that. So Percival Lowell began drawing these drawings, but to him, these were canals built by Martians. Wherever these canals came together, there was pumping stations that would pump the water along the canals and irrigate a dry and dying planet. One of the reasons why he believed that is because of evolution. Now, this was not evolution like two bacteria combined to make a higher level animal. This is evolution of a civilization. It was thought that back in the 1800s, towards the end of the 1800s, that we as human beings were getting better and better and better, and that pretty soon all war would be eliminated and everybody would be enlightened and the world would be a wonderful place in which to live. And that worked out really well until 1914. Anybody know what happened in 1914? Seriously?
World War I?
World War I. The Germans invaded Belgium. And Belgium was a neutral state. And so when the Germans crossed the line into Belgium to go attack the French and the British, World War I started. World War I totally destroyed that concept of a societal evolution, that we were getting better and better. And then after World War I, you have the Russian takeover, or the Soviet takeover in Russia, which turned out to be an absolute disaster. Millions died, starvation, violence, everything. And then we have the Cold War after World War II that primarily came out of the problems between World War I and World War II in the Soviet Union at that time. So this whole idea that this was a noble race of aliens building a better community and their world was dying, so they made all these canals. Whenever Lowell went to give a lecture, thousands of people would show up. Not hundreds, but thousands. And a lot of times they were in halls that could only hold 500 or 600, and there were people standing along the aisles, there were people outside listening through the windows. There was one time that there was a snowstorm going on outside, and they opened all the windows of the building so all the people standing out in the blizzard could hear Percival Lowell give his talk on the Martians. So Lowell was very popular, and Lowell also was not a very good scientist. I've known 4 of the last 6 directors at Lowell Observatory, and 2 of them agreed with me that Percival Lowell was not a particularly good scientist. And part of the reason is because if Lowell had an idea, he went to the press and he would tell them. And then he would write a paper about it. And really what you should do as a scientist is you write a paper, let everybody else check your work, and then if it holds up, then you call a press conference. But that's not how he worked. And so Lowell was often seen as a glory hound, as a guy who was trying to find scientific, I'll call it salvation, that people would say, oh, he's a great scientist. So this is his version of more advanced maps. And remember, all of this was done by eye. The photographic plate was not sophisticated enough to be able to take planetary images yet. And so consequently, everything was done by eyeball. So all of these maps are not particularly precise, because even with the best sketch artists, you're never going to get it quite right. And that was a problem also with handmade maps back in the early days of the United States. Ulysses S. Grant loved to make maps, and he often would, before a battle, go to the front lines and draw a map and then send that map to his commanders. And they often had better maps than what the government had at the time because he was good at it. But even then, they weren't always right. There's one or two battles where the men got in difficult situations because the maps were not accurate. So, we're going to add this guy, E.E. Barnard. I have mentioned him before. E.E. Barnard was a newspaper man. That's what his job was. He actually went to work for a newspaper and he did some early photography that showed up in the newspapers and all that. But he was also an amateur astronomer. And he got so good at it, he was offered a full-time job at Lick Observatory on their new 32-inch refractor. And E.E. Barnard, I think, was probably the greatest observer in American history. There was one or two Europeans that might have been on the same plane, but this guy did a lot of stuff that nobody else did or even thought about doing. He also was the first one to be able to use the new technique of photography to actually do deep sky objects. And he modified a telescope at Yerkes Observatory later on after he left Lick in order to do that. So this is him, and this is the 32-inch Lick. You see this? There's a circle around here. Anybody know what this is for? What do you use that for? That's mounted on the telescope.
Micro adjustments?
Well, close. Macro adjustments. So the problem with these telescopes, see, they did have some micro adjustments. That's what these little knobs and things are. But notice how big they are, because you're moving this 100-ton telescope with these tiny little wheels. So what this is, though, is you didn't have like a control pad that the telescope would automatically go to that location. You do like we do upstairs, where you have to horse that thing, and you have to move it by hand. So the bigger telescopes have this ring around it. The Clark telescope at Lowell Observatory does not have one, but the Astronomy Club in Columbia is working on building one for this telescope to make it easier to move around. And like if it's a little bit off, trying to grab down here and move it, but if you have a big thing to grab on, you got a lot more leverage that you can do. So anyway, I've actually gotten to go up close and actually touch the telescope. They don't usually let tourists do that. But I was at a conference, and the lady in the gift shop, her husband worked there, and there was nobody in the gift shop. So she said, how about if I give you a tour? So we went to all the cool places the normal tourists don't get to go to. They have a 40-inch telescope near the gift shop they use to test equipment before they put it on their 150-inch reflector. And I got to go look at that, pick up some cameras and look at some spectroscopes. I mean, to me, it was like seeing the Holy Grail. It was a lot of fun. All right, so this is the 40-inch Clark refractor at Yerkes Observatory. This is a telescope E.E. Barnard used to debunk the canal controversy. So people are fighting over this silly canal thing. And I have to admit, as a kid, I wanted the canals to be real just because it's so cool. I mean, think about this. You go to Mars and you're greeted by Martians. I mean, that would be awesome, right? But the reality of it is not nearly as romantic. Not even sure, they're pretty sure life existed at one time, but it doesn't seem like there's any now. And so, one of the big issues is Lowell made a really big deal about what they called stopping down the telescope. So, if you had a 24-inch telescope, he often ran it at 12 inches, the same size as ours upstairs. And there's two reasons for that. One, a 12-inch telescope is not as susceptible to the vagaries in the air that you would with a bigger aperture. And secondly, because that is what's called a short aperture achromat, stopping it down to 12 inches gave you better color resolution. So in other words, the longer the focal length, and if you shut down from 24-inch to 12-inch, it doubles the focal length. By doing that, it actually makes the colors better. And so you don't see that purple haze around everything that some of you see when you look through the telescope upstairs. So consequently, the big thing was, Barnard said, you can't stop down the telescope. And if you have to stop it down, you probably shouldn't look through it, because you don't have the same resolution. We're not going to go through the math, but basically, the smaller the aperture, the less detail that you can actually see on an object in space. So a 40-inch telescope will see about, I don't know, 20, 30, 40, 50 times more detail on a planet than a 12-inch will. I don't remember the exact math on that. So Barnard looked, and Barnard saw something that nobody else could confirm until Mars orbiters started going around Mars. And that is, he saw actual rough patches of ground where other people just saw smooth orange color. And he may be the first one to have seen a crater on Mars. He actually thought he saw one. Theoretically, the 40-inch is just barely large enough to get to see a very large crater on Mars. But he never actually officially reported it because it was a fleeting glimpse, because the atmosphere of the Earth is so bad, especially up in in Williams Bay, Wisconsin, where the Yerkes telescope is. So consequently, he pretty well destroyed Percival Lowell's version by actually using good science to disprove it. And so several of you are probably saying, well, so what? Who cares? Well, there's a reason for all of this that we're talking about it. Onto the scene next comes Vesto Melvin Slipher, VM Slipher. We talked about him at some length when we talked about spectroscopes and spectroscopy, because VM Slipher was the guy who discovered that 21 nearby galaxies were all either moving away or moving closer to us at high speed by using spectroscopy. So, I just pulled this off the internet. Slipher revolutionized cosmology by initiating the study of galaxy redshifts. In 1912, he discovered that most spiral nebula, they weren't called galaxies back then, were moving away from the Milky Way at massive speeds, radial velocities, providing the key observational evidence for the expanding universe. So, again, 1905, Einstein began to lay the foundation for an expanding universe. But nobody really knew anything until VM Slipher came up with these figures. This is a spectroscope or spectrograph of Slipher looking at the Andromeda galaxy. Andromeda is M32. It's the closest galaxy to us. In the fall, late fall, like in December, you can see it almost directly overhead, and it's actually about the size of the full moon. It's just so dim you can't see all of it without a telescope. But it's the closest galaxy, and it turns out that it's coming at us at a high rate of speed. It's the only galaxy that has been found from the Earth that is coming towards us. All the rest of them are moving away at a very fast pace. But notice this. This is 1 centimeter. And if you remember, an inch is 25.4 millimeters. So this is about 4 inches long. These marks right here, up here, these are, it's a spectra where they shoot a light through the same spectroscope so that you can then measure the lines here from the galaxy according to known, according to known elements and the lines that they project. Okay, does everybody get that? Yes, are y'all still with me? Maybe. Some of you guys are like, I'm trying, but it's not working. So, and I wanted to show this to you because this took 8 hours of hand guiding. Now, if I was going to do this today, if you remember the telescope out in the roll-off observatory, it had the big telescope, and then there's a finder scope that you look through, has an eyepiece, and then there's another scope that has a camera on it. And the camera is about the same, it's on a telescope about the same size as the finder scope. And what that is that will lock onto a star, take a picture every second, and as that star moves, it will actually adjust the mount so the star stays right in one place. You don't have to adjust the telescope. This telescope has a hand control. And when people used to use these to do imaging with, which was really a pain, by the way, what they would do is you would look through another telescope, usually mounted right here, and you look at a star under high power with a crosshair in it. And then you would actually move the telescope and keep that star centered in the crosshair. And a lot of times the telescopes would have like 1,000 power. And so you'd look at a fairly bright star and you'd see just a little round mushy thing, and you tried to keep the round part in the center of that crosshair. Well, back in the time when Slipher was doing this, you used about a 6-inch telescope at 1,000 to 1,500 power, and you kept the telescope either with a hand control, or sometimes you had to bump it with your body. So when the telescope started going out and it wouldn't respond to the hand control, which was pretty common at Lowell Observatory in the wintertime because all the grease would get thick and it didn't want to work, he would actually push his shoulder against the telescope to get it to move. I cannot imagine spending 4 straight hours staring through a telescope, adjusting and you can't walk off for 20 minutes. You just can't do it, or everything is ruined. So if we had more time, which you'd probably be bored out of your mind anyway, I'd tell you how a spectroscope or spectrograph works for something like this. It's really difficult to do. It's even difficult today, and today you use multiple cameras so that we'll track accurately. All right, this is Slipher is a senior adult, and if I remember correctly, the first time I went to Lowell Observatory, I was probably about, I think I was 7 or 8. We were still living in Colorado, and we had gone to Arizona, and then we went to Flagstaff, and I bugged my parents about going to Lowell. I believe this is the guy, and at the time, he was head of Lowell, who gave us a tour. Can you imagine being the head of an observatory and one of your jobs is give tours for an hour to tourists? But twice, as a kid, the director of Lowell Observatory gave me a tour. And I actually had another tour, but that was just because, I don't know, I was a fellow teacher, I guess. But anyway, so Slipher should have gotten accolades as being one of the great pioneers in spectroscopy. And if you remember, I told you the story of Percival Lowell ordering that spectrograph, and it comes in and they open up the case and Slipher says, "Oh, that's really great." And Lowell says, "Well, I'm glad you like it because you're the one that's going to have to use it." And so Slipher, who'd never been trained on it, there wasn't very many people trained on a spectrograph back then, started reading papers and experimenting, and after a couple of months became one of the world's leading experts on how to use a spectrograph. So in 1913, he published The Radial Velocity of the Andromeda Nebula. That was his first publication. He discovered this in 1912, and it was coming towards us at 300 kilometers per second. In 1914, he just wrote a note in Popular Astronomy and reported radial velocity for 3 more spirals. Popular Astronomy was pretty much an amateur thing, but a lot of professionals gave reports about their work in Popular Astronomy. In 1915, he published a more complete table of 15 spiral nebula in popular astronomy, showing that 11 of them were receding. And in 1917, he finished and published his paper on this. So I have two questions. Why did it take V.M. Slipher so long to publish his work? And why do you think he was all but forgotten for his important contribution? Because really, very few people actually remember V.M. Slipher. It's not a name that an astronomy person would probably conjure. So here's what you're going to do. You're going to get with people in your area and spend about 5 minutes talking over these two questions, and then you're going to give me some answers, okay? So, yeah, move.
Video, there we go. That's nice.
I think the first one is you want to make sure you're right. That's why you get publishing stuff in our paper.
Yeah.
And then it's forgotten because he took so long to publish it.
Yeah. I mean,
He probably wanted to do something important before he died, so he had to do that. This is his last resort.
Here are the people in the back. You guys aren't saying anything, are you?
We were gonna talk.
yeah, we did.
Oh, you already figured it out? Okay. Not real hard, actually, but I just figure after sitting there as long as you have so far, making you move a little bit, it's not going to hurt anything.
What did he do?
And then people are like, oh, like people that do that, they talk about.
Yeah, that's a good answer. I like that one.
That was good.
She
Yeah,
ate
that was good.
What you did? I didn't think of it anyway.
I think we got some answers over here.
Yeah.
Okay, so let's go ahead and get back to it. So what is the first one? Why did it take V.M. Slipher so long to publish his work?
We said that we think that he just wanted to be certain, really double check all his work, make sure he got it correct before he finalized it.
How many of y'all agree with that? Yeah, I think that's probably the case. And remember, who was his boss at Lowell Observatory originally? I guess I neglected to mention that, but
I think I just
Percival Lowell was his boss. Was Percival Lowell a good scientist in that he checked all of his work?
Yes.
No, he was not. Good guess, though.
I like the confidence.
Yeah, Lowell was the guy that published it first, then he wrote the papers on it.
Right.
And Slipher wanted to make sure if he published anything, it was as good as it possibly could be. So some people would have published the first month they discovered it. It took him a year before he made his first publication. And then it took him until 1917, from 1912, to publish all of his findings, okay? So why do you think he was all but forgotten for this important contribution? Yeah.
But you kind of talked about maybe the fact that like because it took him so long to publish, people weren't like, talking about it as much, and he may not have like gotten to like talk about it and like publish as many things as he wanted to before he like stopped.
Okay, yeah. There's something that happened in 1932 when Clyde Tombaugh discovered Pluto. Slipher was a little upset that Tombaugh wasn't telling the press it was a team effort to discover Pluto. So Slipher was cut of a completely different cloth than Percival Lowell. Lowell would have gloried in that, and if Lowell would have still been alive, he would have been the guy that all but discovered Pluto, because that was his nature. He was a larger-than-life character, had at least one mistress, if not many, was a multimillionaire who traveled all over the world doing all sorts of crazy stuff. Slipher and his brother were also from the Midwest. I think they were from Illinois, but I can't remember. Illinois or Indiana, I'm not sure which. And they were very quiet, very calm, and they were very thorough. the exact opposite of Percival Lowell. Though, in Lowell's favor, he hired 2 guys that would take their time and make sure it's done right, even though he didn't always do it that way. So, I think part of it is Sleeper was kind of a boring guy. And you look at people like Edwin Hubble that we're going to look at in a few minutes, he was anything but a boring guy. And so consequently, I think it's easy to lose Sleeper with all of these larger-than-life personalities we're going to look at. So this guy, Alexander Friedman, he was actually the founder of the expanding universe theory. He looked at Einstein's math and he removed the cosmological constant. And when he did that, the universe either had to be expanding or contracting, and he believed it was expanding. Now, Friedman fought in World War I. He was eventually transferred into the artillery, and after the war was over, he actually led a factory. And pretty much, if you were the leader of a factory, you're a member of the Communist Party. And so in 1925, he suddenly died. But Einstein and he actually were exchanging letters, and Einstein was saying you can't remove the cosmological constant, and Friedman said it was a mistake. And later on, in 1931, Einstein admitted he made a mistake and that Friedman was right, and so was Edwin Hubble on his results. So in 1922, introduced the idea of an expanding universe. I'm not going to read all that, you can read it. But I thought it was interesting that Friedman, who was in a communist country that was in total chaos in 1925, was actually willing to challenge, and by the 1920s, Einstein was considered to be one of the world's great geniuses. Maybe not as much as he was by the time he got into the 30s and 40s, but Friedman, I thought, was a pretty cool guy that he was willing to take on Einstein, and he was right. Einstein was not. So the next guy, I find this guy absolutely fascinating. Developer of the expanding universe. Now, Friedman did the math, Einstein laid the foundation, V.M. Sleeper discovered the first indications that the universe may be expanding. But Georges Lemaitre, who is Belgian, he was the developer of the expanding universe leading to a beginning. Now again, remember, I said scientists don't like the idea of a beginning. And when we get to Fred Hoyle, we'll talk about that in a little more detail. But the idea of a beginning, according to Hoyle, smacks too much of religion, and he didn't like religion. And so Lemaitre, though, was a priest. And he actually also fought in World War I. He was in the infantry, and then he ended up in the artillery. Because why in the world would you get one of the world's greatest physicists and stick him on the front line with a gun shooting at people? It's just stupid. And so once they figured out this guy was really smart, they put him in artillery. Anybody know why you put a mathematician in the artillery area? Why would that be important? I'll give you a hint. Edwin Hubble, during World War II, went and worked in artillery in the United States, preparing new weapons and trajectories. Yes?
It's so like you can like figure out the angle and the windage with the kind of aim stuff.
They actually had charts and books that they would put out with their guns that would give you, if you angle it this way and use this much powder, you will actually go this distance and yada yada yada. Nowadays, that's all done by computer, but back then they used tables. Somebody had to develop the tables, and he wanted a mathematician to do that. In fact, Lemaitre had this issue. He actually got court-martialed in World War I because when he was in the artillery unit, he pointed out a mistake in the handbook, and his commanding officer took offense, and he was censored. But at the end of the war, they gave him 2 medals for bravery. And one of the reasons is because when he was fighting, he was actually an incredibly brave guy in the middle of the fighting. And then he also stood up to his commanding officer and said there was a mistake in the tables. So if you used the tables, your gun wasn't going to shoot right. And so he actually got an award for that. I thought this was interesting too. If the Bible does not teach science, among other things, what does it teach, you ask? The way to salvation, comes the reply. Once you realize that the Bible does not purport to be a textbook of science, the old controversy between religion and science vanishes. A lot of people don't agree with that today. And I agree with the statement to a point, but there are other people that say, well, the Bible is a book of science. And so it kind of just depends on how you interpret it. But he was a guy who came up with a theory of reconciling the creation story in Genesis with science, but a famous person that he talked about it to told him not to put those two things together because it just confused people. I think it still does. I call that a distraction. Young Earth versus old Earth versus eternal galaxy versus an expanding universe, a closed universe. I mean, all of that stuff, it becomes a test of faith in religion. It's a distraction. All right, this guy, Millikan. Anybody ever heard of Millikan? There is a university in Illinois named Millikan. I think it's Illinois. But that's actually named after a businessman, not this guy. Millikan was the head of the University of Chicago. When he went there, their first building was right off a dirt road, and they had no faculty. And Millikan was tapped to actually build the University of Chicago. By the time he left to go to what became Caltech, the University of Chicago is one of the world's great institutions, still is. In fact, my student tried to get into University of Chicago. He was a straight A student here. He had a double major, astrophysics, mathematics, with a computer minor, all of which were the highest grades you possibly could get in every single subject, and he did not qualify to get into the University of Chicago. He got a full ride scholarship, though, at Illinois Technical Institute, which is pretty good in and of itself. And I mentioned he's working at Fermi Lab, which is a radiation lab in the Chicago area this summer, very prestigious. So here you have Millikan, who's one of the great astrophysicists, and he won a Nobel Prize, and he actually was a great administrator, and he also had something to do, he was on the committee to look into whether or not they should build the atomic bomb in World War II. This is Lemaitre, and of course, who's this one? Oh, come on.
Einstein?
It's Einstein, yeah, you can tell by the hair. And did I mention that Einstein was a ladies' man? He actually would walk into a cafe and all the waitresses would fight to wait on him. And he had a whole series of mistresses by his own memoirs. So I just find it interesting because when you look at this guy, does he look like a woman killer to you? I wouldn't think so. But he was a really hot commodity from what the writings talk about. So, yeah, whatever. I have to admit, 46 years with my wife, I cannot imagine having a mistress. It just does not compute in my head. All right, Edwin Hubble, Midwest boy become British. So this guy has a space telescope named after him. The Hubble Space Telescope. Have you ever heard of the Hubble Space Telescope? I hope you have. It's probably one of the most innovative telescopes of the 20th century. And he is from, let me just go to this one. He is from Marshfield, Missouri. But if you met Edwin Hubble, you'd think he was British. He wore tweed jackets with the patches on the elbows. Anybody know what I'm talking about? You know, the stereotypical British guy, smoked a pipe, and he spoke with a very high-class British accent. Though, according to the guys that worked with him, when he got really angry, he sounded like a hick from the Midwest. He would forget his accent and because he was too excited. So Hubble, I don't think I would like Hubble, particularly if I ever met him, though he probably wouldn't talk to me anyway because I'm not important. But at the same time, Hubble was a groundbreaking scientist. The thing that always bugged me about Hubble was he's a guy that took other people's ideas, synthesized something with them, and never gave credit to the people whose ideas he took. So Henrietta Swan Leavitt came up with the Cepheid variables and how to use them as a standard candle to find distances to nearby galaxies or clusters here in our galaxies, what she did, discovered that with. He took that technology and he combined it with V.M. Slipher's redshifts, and then his big contribution is putting those two things together and finding Cepheid variables in the Andromeda galaxy, figuring out the periods of those Cepheids, and then that told him how far away that galaxy was. And to the day of his death, as far as I know, he never thanked V.M. Slipher or acknowledged Leavitt. And that always kind of bugs me, because if I get up here and I'm talking, often I'll tell you where I got this information from, because I think that's important. If somebody does the work, they should be acknowledged for it. How many of y'all have been to Marshfield, Missouri? I know I have, but it's not one of those places I really remember. So, and if you're from there, I apologize. Actually, I think it's probably a good place to live, but this is Hubble on the 100-inch telescope at Mount Wilson. Much of his work was done on the 100-inch telescope. He started on the 60-inch, and then he got to the 100-inch. And at the time, Mount Wilson, and he was on staff at Mount Wilson Observatory, they got all the time on the 60-inch reflector and the 100-inch. And he did the bulk of his work, including getting new redshifts and looking for Cepheid variables with the 100-inch telescope. And then when the Palomar telescope, the 200-inch, opened up in 1947, he got a lot of time on that one as well, though by then he didn't actually do much observing. He had a mule driver, which is a story for another day. A guy who originally was driving mules up Mount Wilson taking supplies. The astronomers liked him so much, they hired him on to run a telescope, and then pretty soon he became a full-fledged, highly paid astronomer, if you call what astronomers make highly paid, and he was Hubble's assistant. And so I've always thought he would be a more interesting guy to know than Hubble was. So this is Hubble in the 200-inch. This is where you sat. There was a ramp that would come out and you would step across a chasm about this big, that was about 150 feet in the air, and you would step into here and you would look at an eyepiece in here, find a star, and you would use a hand box to keep the telescope centered so that you would have an accurate photograph of whatever you were taking. So by this time, Hubble was not he never was a guy that liked doing the telescope work. He liked doing the follow-up stuff, looking at the pictures, measuring, all of that. But when he got old enough to get an assistant, Humason was his assistant's name, Humason did all that work for him, and very seldom did he observe. Well, one thing that Hubble did well, he went to Oxford when he was in college. He developed the British accent and all the British habits. When he came back to the US, everybody thought he was British. And he never disabused them of that idea. He practiced law for 6 months and hated every second of it. And then he went back to school and got his astronomy degree and went to work at an observatory. He also married a Hollywood socialite who knew everybody who was anybody. And according to a lot of biographers, people like Clark Gable came over to his house, and all of these big name stars from the 30s and 40s were regular attenders at parties at his home. And so those of you that think science people are really stuffy and boring, there are exceptions to that. And in fact, I've very seldom ever met a stuffy, boring science person. But some of you might think they were stuffy and boring. I just find science really fascinating, so it's a little easier for me. But anyway, so Hubble was the first one to really discover the distances, to put all the boxes together, get the distances, and then see the correlation between the red shift of a galaxy, the red or blue shift, and the distance. Here's some spectra. I don't know if these are actually Hubble's or not, but these would be very similar. Up here are the calibration wavelengths. A lot of times these are hydrogen. And then this here is, this in the middle, is the actual spectra of the galaxy. So we can do some of that here, especially with the telescope out in the roll-off, but we just haven't done that much. The weather has not cooperated. And the telescope wasn't working for the first couple of times when it was. So I'm hoping before the end of this semester, we will take some actual spectra through that telescope out there, and you'll be able to actually see with your own eyes something that we've been able to take an image of with one of our telescopes. 1929, Hubble published the redshift versus distance relationship, showing that all the galaxies in the neighborhood recede at a rate proportional to their distance. And this is Hubble's law. The redshift Z, and that's what you find. You look at the calibration lines, and then you look at the lines of the galaxy, and the distance between them is Z. And that's how much it shifts. And it is proportional to the distance. And there's a funny story about this arrow. When I found this formula and I put it on there, this is what they had instead of an arrow. And I thought maybe I was missing something. Now, I took it over to Dr. Schwischke, and he looked at it, and his thing was, I think that's an arrow. Well, the paper I was looking at was old enough. It was before you had all the really cool stuff you can do with Word and all that. So consequently, this was an arrow, but I wasn't sure that it wasn't some weird high-level mathematical symbol. So what I did is put an actual arrow in here. You can see the end of the equal signs. But yes, this is supposed to be an arrow. So this is saying Hubble's law is the redshift Z is proportional to the distance. So the higher the redshift, the farther away the galaxy or the object is. Now this is the guy that I think is absolutely fun. And I'm going to show you this picture of Fred Hoyle. This, according to everything I've been able to see and all the reading I've done, I've read about 4 or 5 of his books, Fred Hoyle was just a character with a capital C. He and Alan Bondi and a guy named Gold were sitting at an English pub drinking beer. And they had a bunch of napkins on the table, and they were using pens and pencils to draw mathematical formula on napkins. And yes, scientists do that. I've done it myself with a group of scientists a couple of times. It's kind of fun, actually. As long as they're not cloth, they really frown on you for using cloth and writing on it, just saying, because that doesn't come off very well. So they're sitting in this pub, and Hoyle says, I really hate the idea of a beginning to the universe. And when one of the others, I think it was Bondi, asked him about it, he said, well, if you go back to the Bible, in the beginning, God created the heavens and the earth. And that smacks too much of religion to me, and we need to do something about it. So they sat there for a couple of hours and drew out the foundation, the mathematical foundation, for what was called the steady state theory. What did I do with my... Steady state. So the steady state, as far as anybody is concerned in science, a lot of scientists, is the perfect idea for the universe. It doesn't expand, it doesn't contract, it's always there. If a star dies, there's hydrogen being created out of nothing at the center. And that's one of the things Hoyle came up with, is yes, the universe looks like it's expanding, but what's really happening is hydrogen is being replaced at the center of the universe, and as it expands out, everything expands with it. And he really liked it because there was no need for God, there was no need for math that even to this day no one's been able to come up with to explain how you have a singularity that creates a Big Bang and brings the universe into existence. So, if you've been following any of the nonsense on YouTube or TikTok or whatever about the new discoveries with the James Webb Telescope, you'll see Big Bang is dead, things like that. Well, that's not really true. What's happened is theories are having to be changed, and we've talked about this before. So Fred Hoyle came up with this steady state theory, and he made it very popular. There's only one teensy-tiny problem with it. It never worked. There is no evidence to this day of a steady state theory. None. Zero. Zip. And though he never renounced the idea, he at least wasn't as angry about it later on. And Hoyle, who was knighted, who was known as a huge atheist, about 2 or 3 years before he passed away, he was at a conference, and maybe I told you this, if I did, I apologize. He was at a conference which was Science versus Religion. And they put his name next to the moderator on the atheist side. The science, the atheist science didn't believe in any kind of deity or anything. And then a few scientists and some clergy and stuff were on the other side. Well, when Hoyle came into the hall, he walked up to the moderator and said, "You've got me on the wrong side." And he grabbed his card and moved the other guys over that was there, and sat on the side of religion. Now, he was never a believer. He never did accept the concept of a God or anything, but his studies, he came to 2 conclusions. And let me move on with this. So, once we see, however, that the probability of life originating at random is so utterly minuscule as to make it absurd, it becomes sensible to think that the favorable properties of physics on which life depends are in every respect deliberate. It is, therefore, almost inevitable that our own measure of intelligence must reflect higher intelligence, even to the limit of God. Now, this is called anthropic fine-tuning. It's the idea that we live in this finely tuned universe that couldn't happen by random chance. Hoyle came up, again, towards the end of his life with a paper. He'd been studying the development of carbon in stars. And it turns out that the conditions to make carbon, of which is very abundant on the Earth, is almost impossible to get without fine-tuning in the universe. And so he had the idea that there was some intelligence that actually created or at least spread life in the universe. Now, again, he was never a believer. He wasn't a Christian, wasn't a believer in any kind of deity or anything. But there also was a movie, oh my gosh, I'm forgetting the name of it. It was a science fiction movie where they go to a planet and they find the remains of a civilization and all that sort of thing. And at the beginning of the movie is a creature coming in from another planet or solar system or galaxy, and he comes in and he makes life happen on the Earth. That was actually Fred Hoyle's idea, that there was some super intelligent race that was going out and seeding life in the universe. Anthropic fine-tuning. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. A friend of mine, Dr. Robert Evans, who is a pastor in Coonabarabra, Australia, who also happened to be the #1 discoverer of supernova visually, sent me a paper all the way from Australia, and unfortunately I can't find it, but it was actually Fred Hoyle's article or journal article that he wrote about the impossibility of evolution, the way it's presented in our schools today. The reason why this created such a stir is that quite a few scientists still don't like the idea of a beginning. They don't like the idea that there could, if there's a beginning, it implies there's a cause. Well, what is the cause? Well, the most logical cause would be a creator who caused it to come into being. So, they didn't like that. And for various reasons, it doesn't really matter why, psychology of it's not all that important. But evolution is one of those things that when I was in school, I was told it's a fact, and there is no disputing it. That has come under a lot of fire recently, and I'm going to give you one example. How many of y'all have ever seen in a biology textbook the experiment where they take early Earth gases, put it in a jar and shoot lightning bolts through it, and it makes amino acids? Anybody seen that? Can't think of what the experiment was called. Well, that's still in all the books. It still talks about evolution, but there's only one small problem with it. The early Earth had none of those things. The early Earth did not have a large amount of methane. It didn't have, and the reason why they know that is occasionally you get a rock that still has early Earth atmosphere in it. And then you can actually measure it and see what the early Earth atmosphere is like. And it turns out that that was a great experiment. The Michelson-Urey or something experiment. And so that's still in all the textbooks saying, yes, evolution is possible, but it actually is inaccurate. And I saw a thing not too long ago written by a non-Christian biologist talking about all of the fallacies you still find in textbooks that have been disproven along the way. So we're not talking about science versus religion, but Hoyle did the math, and he came up with the idea, and the numbers were so impossible from a statistical standpoint that life being coming into existence through random chance, according to him, was impossible. So, not too long after he published that paper, physicists came up with a different way to do it. And that was the multiverse. Anybody ever heard of the multiverse? Yes? No? Yeah? So what's the multiverse?
The idea that there's multiple universes and we're all like right along the same thing, but one event causes a different universe to show up.
So you have an infinite number of universes in which virtually any universe like we have that seems to be fine-tuned for life and for physics, eventually with an infinite number of those universes, you will have one where it overcomes all the statistical impossibilities. Anybody know what the problem with the multiverse is? Well, there's two problems. One, there's no way to prove it. We only have 4 dimensions. 3-dimensional, the normal 3 dimensions, and time. That's all we know. That's all we can measure. There's no way right now that you can go to another dimension and measure anything else. Secondly, if there isn't a multi-dimensional type of space, then that creates a huge problem for evolutionary biology, because having life spontaneously erupt and end up the way we are at this time period, according to Fred Hoyle, who was very well respected at the time, still is, it's impossible. So if you have a statistical impossibility, then you got to look for an alternative, and the alternative a lot of people don't like too well. And yes, I am a member of the Scholars Community of Reasons to Believe, which is an old earth group of scientists who actually look at things like this. And that's not really what this talk is about. But I just found it interesting that Fred Hoyle, towards the end of his life, said, you know what, I've been studying this all my life. And there's something wrong with where we're headed with how we think about these things. And of course, he was definitely not someone of faith, but he also wrote a really popular book called The Black Cloud. Anybody read The Black Cloud? I'd actually encourage you to read it. It was written in the 1950s, but it reads very much like a much more modern scientific or science fiction book. And it's the idea that there's this black cloud, and it comes in and it surrounds the sun, and it cuts off the light of the sun from the earth. And they find out the black cloud is actually a living being, and it doesn't know that there's actually life on earth. And they figure out a way to communicate with it, and it's getting enough energy from the sun that it will then go to another sun and leave the earth to survive. But they know approximately how long they'll have to do. It's really quite a fascinating book. And Fred Hoyle was a guy, whenever he was going off to do observations or traveling, he always took science fiction books with him. Some guys took, journal articles to read. He read science fiction books. And there was one scientist, I can't think of which one it was, who read Western novels. He loved Zane Grey, and he always had a Zane Grey novel. Go figure. Y'all even know who Zane Grey is? Oh my God, okay. How about Louis L'Amour? Louis L'Amour? So Louis L'Amour was a guy, 50s, 60s, 70s, 80s, who wrote a slew of cowboy books. Zane Grey wrote in the early 1900s. And I have to say, I much preferred Zane Grey. In fact, his original version, not the abridged version that was published, of Riders of the Purple Sage, is one of my all-time favorites. All right, so we've talked about Fred Hoyle. Oh, I forgot to mention the most important fact about Fred Hoyle. In derision to George Gamow, he said, well, yeah, you guys have this Big Bang that you're studying. Well, it's stuck. So that term is still used to this day. So the scientific name for an expanding universe from a beginning is the Big Bang Theory. Not the TV show, but the actual event, okay? And so George Gamow is the guy who came up with that. He also was born and educated in the Soviet Union. And in 1933, he and his wife finally got permission to go to a scientific conference where the other scientists helped him to defect, and he eventually came to America. Now, they tried in 1932 to get out of the Soviet Union. The first effort was to paddle a canoe 250 kilometers from the top of the Black Sea down to Turkey. Well, bad weather forced them to go back, and the government did not know they were trying to escape. So that was good. Because if you tried to escape, usually you got shot. That's pretty much how it worked. And then the second effort was in a small boat up in the Bering Sea to cross over and go to one of the Scandinavian countries. That didn't work either, and it turns out that the government didn't know about it. Because again, they would have been imprisoned, shot, or whatever for trying to get out of the Soviet Union. And by the way, being a history guy, it's one of the reasons I'm not a big fan of socialism or communism, because every country that does that, you do things like shoot people for trying to get out of the country. And so one of the great things about America is if you don't like what's going on, go to Canada, go to Australia, go somewhere else. It's okay, we'll let you do that. But if you are in a socialist country like Cuba or Venezuela or whatever, you got to jump through a lot of hoops if you want to get out of that country, because they don't want you to go. All right. He became a naturalized citizen in 1940. And so Gamow was the guy who did a lot of the mathematical development to come out with the full-blown theory of the Big Bang, the expanding universe, from what's called a singularity. Now, it's a little confusing because the center of a black hole is called a singularity. But a universe that explodes and begins forming this universe is also, that area that it's coming from is also called a singularity. So in a black hole, a singularity is crushing matter outside the universe, as far as anybody can tell, because nobody can get in there to check it out, and the math doesn't hold up. But in the Big Bang, it's the idea of that singularity giving out that material instead of crushing it. And so it's very confusing, and it makes scientists very uncomfortable. So we're going to move on here after Gamow, and he became a very distinguished American. In fact, as he's called a Russian-born or Soviet-born American citizen. And he became, he even did some consulting on the Manhattan Project, which is the atomic bomb. So these two guys, I've always thought this is a great story. In 1964, Arno Penzias and Robert Wilson discovered a faint hiss of radio interference coming from every direction in the sky. This was identified as the afterglow of the Big Bang, providing the definitive evidence that the expansion began from a hot, dense state. So this is Wilson, this is Penzias. They won the Nobel Prize, but there's a great backstory to this. There was a team at Harvard University about 20 miles away from the AT&T laboratories where this was going on. And these guys were just trying to find out why there was so much noise in the background in radio waves. And that was their job, is to find that noise. So they had all sorts of issues with this thing. This is their, they called this the, oh my gosh, the funnel, or the horn. It's called the horn. It's actually a horn antenna. It's a type of antenna. But it was movable and steerable and all that. And so they found that this cosmic microwave background, CMB, was always there. And it didn't matter which part of the sky you turned it to because you got it. And they went to this group at Harvard and said, hey, we've discovered something and we just want to make sure we have it right. Well, when that group of 2 or 3 senior scientists and a bunch of grad students looked at the data, they realized they'd missed their Nobel Prize, that these two guys were going to get it for discovering cosmic background radiation. So Einstein laid the theory, Friedman did the math, Gamow and Hubble, Slipher and Hubble did the proof, Gamow laid the theoretical foundations of the math, and then now these two guys find the last major evidence for the Big Bang. This is the Kobe satellite. And this, I just put it up here. It's not all that important that you know all these different things in here. But it actually was able to find irregularities in the cosmic background radiation. Because according to the theory, if there was this big giant explosion, it wouldn't just be a smooth wall of energy. Because what Penzias and Wilson found was pretty much smooth. There were some lumps in it, but not all that much. But that was because their equipment was pretty low resolution. This made the resolution at least 100 times better, and it actually shows a lumpy universe. And so here is what they discovered. This is the cosmic background radiation. You see all these red things and all of this. This actually goes along with the mathematical foundation that all these other guys had come up with. So I find it fascinating because you've really got to get past the cosmic microwave background if you're going to come up with another type of cosmology that is not a Big Bang. Because in a steady state, there would not be anything remotely like cosmic background radiation. And so that pretty well killed any type of steady state or anything else. So when people talk about the James Webb as showing that everything is going to change and none of the, okay, it's not. And in fact, the few people who've come up with an alternative theory have to change the laws of physics to make it work. So there are people who say, well, light is behaving differently at a distance. But I don't think so, because one of the things you can tell is you actually have a pretty good handle on how light performs because you can test it in the laboratory. And the fact that it would change over distance, what's that mechanism of change? Yes, dust will redden the light a little bit, but not enough to change its properties, which is what you have to have with all the other. Does that mean that somebody won't come along with a different theory someday? No, they probably will. And they may come up with something better than this. So this is kind of giving you an overview. You have the singularity here. You have inflation. This is the first few seconds, and it expands at this high rate. And then you have all of the universe forming and all that sort of thing. This is already out of date because James Webb has been finding very large galaxies back where they shouldn't be. The idea was right after the Big Bang there'd be these little small galaxies forming. Well, instead they're finding these massive galaxies forming not too long, like 300 million years after the Big Bang. And so if you find results that are different than your theory, what do you have to do in the scientific method? Anybody know? Oh, come on. You can figure that out.
Yeah.
Well, if you don't have something right, what do you have to do? Make it right?
No.
Okay, yeah. So you have to change your theory. I look at it this way. Faulty premises lead to faulty conclusions, correct? So if you come out with a faulty conclusion and your conclusion doesn't match what you're observing, then you got to go back and look at your premises and make sure that you're using the right premises to begin with. So this is kind of the latest of cosmology. You've got 68% dark energy, which a lot of scientists think are fueling the expansion of the universe. It's actually accelerating instead of decelerating. And then you have 27% dark matter, but only 5% is what you see. And Dr. Tony Tyson, who was one of the early developers of the CCD camera, said in the book and the video called The Astronomers, he said, the universe is predisposed to things that glow in the dark. So this 5% are those things that glow in the dark, primarily. And this is where dark energy and dark matter is where my research student has decided to work on his PhD. So the cool part about it is, if they are successful in what they're doing, he might get a Nobel Peace Prize. Now how cool would that be? That one of your former students goes on to get a Nobel Prize. That would be awesome. And so, you know, this is kind of what everybody's looking for today. And if you want money, you don't study white dwarfs like I do. You actually study dark energy or dark matter or whatever. This is the Vera Rubin telescope. It's not the world's largest telescope, but it is a short focal length telescope with the largest camera ever built. And the camera, I forget how big it is, it's bigger than a car. And this is its first light image. So it will take a picture, a detailed picture of the entire night sky down to like the 21st magnitude every 3 nights. So every 3 nights it does a complete mapping of the visible sky from its location. So Dr. Tony Tyson, I mentioned, is the primary investigator for this project, and he's one of the ones that helped design it. And I haven't talked to him for a while, but he was really excited about all the work they were doing and couldn't wait for the thing to get online. All right, so that's it. Anybody have questions? Anybody care about anything? Bye.